Okay, so this question, I wanted to first show you where this came from. This question came from, I actually scanned this in. This is the top of a ream of paper, a pack of ream of paper. And I actually saw this when I was standing in line in the grocery store, so I had to buy that paper because it had a puzzle on it. Okay, so back to the statement of the puzzle. Okay, F1 is 1. F2n is the same as f of n, and f of 2n plus 1 is the same as its previous neighbor plus 1. So for example, let's do a few of these, explain what this means. And of course, you're studying for this exam, so you already know the punchline. You know what this is doing. But let's just pretend like some people watching the video don't know. So f sub 1 is 1. And what is f sub 2? Well, it has to be the same as f sub 1. And it means every time you double this number, so like you double the index from 2 to 4, you still get f of 4 is 1. And that means f of 8 is 1, f of 16, 32, 64, etc. Okay. So, then what about 3? 3 is the first time we have to use this formula. This says if you have an odd number, an odd index, you look at the previous even index, and whatever that f value is, you just add 1. So that means when you're going from an even to an odd, you just add 1. So even to odd, add 1, add 1. Are there any other ones in this chart? No, not yet. Okay, but then what do we do going from odd to even? Well, from even, when you're on an even, you look at the previous even value. You go like this. That's half. So you have to take this 6 and divide by 2 to get to 3, and that tells you that 2 is your value. And then, okay, double 6, you get 12, and 24, and so on and so forth. Okay, now what? Well, let's say you have 7. Okay, you want to go from 6 to 7. That you're going from even to odd, so you go from 2 to 3. That's easy. And if 7 is 3, 14 is 3. All right, now what? 9 to 10 is going to even. Oops, we're not allowed to do that. You actually have to backtrack to the, backtrack to 5 and see what the value is for 5. There you go. But then when you're going from 10 to 11, then you just add 1. And when you're going from 12 to 13, you just add 1. From 14 to 15, you just add 1. And then what? 17 to 18. Well, for 18 it's even, so you have to check 9. 9 is 2, so 18 is 2, which makes 19 3. And 20 you have to check back with 10. They have to match. Okay, so there we've got ourselves a chart that gives us the first several values of f. And then we ask the next question. We say, calculate f of 1984 using one of the methods shown in class. Well, you know what? The method that reveals the punchline of this puzzle is the one I'm not going to do on the video, but it is on the practice exam answer key. There you go. So, f of 1984 is the same as f of 992 because 1984 is even. But 992 is also even. Half of that is 496, which is also even. So half of that is f of 248, which is, oh my gosh, it's even. Which half of that is 124, which is f of 62, which is f of 31. Great. And I didn't really plan this. It just worked out this way. It's kind of cool that way. All right, so f of 31 is finally odd. What do we do if it's odd? Well, we calculate f of 30 and then add 1. The f of 30 is the same as f of 15. F of 15 is the same as f of 14 plus 1, so we can now say f 14 plus 2, which is f of 7 plus 2, which is f of 6 plus 3, which is f of 3 plus 3, which is f of 2 plus 4, which is f of 1 plus 4, but f of 1 is 1, so the answer is 5. Okay? So just remember, this is kind of a fluke. I didn't plan this, but the first, going from 1984 all the way down to 31, as you backtrack, we just keep dividing by 2, dividing by 2, dividing by 2. So, for example, f of 124 has to equal f of 62. And just as a fluke, once we got to 31, then we used the other rule. And each time we kept landing on an odd number, and then we would, you know, whatever the odd number is here, you just subtract 1 and get the even neighbor down and add 1. Okay? So, yeah. That was fun for me. I hope that somebody found it fun. And obviously there's another way to do the problem, and I encourage you to read the answer key.